only item on the agenda. If people want to add more stuff, let me know so I can. They can go in front of me if you want. Click on the link. So I mentioned in the previous meetings, I was planning to discuss this subject. The short version is that, well, as you know, we right now Istio depends heavily on the mutating webhook and injection, and that works well. It has a lot of benefits, but it is specific to Kubernetes, and it is a pretty complicated template that you know, it's hard to maintain, and we have all kind of problems with it. The document I'm presenting is based on some work I did to attempt to use Istio, to support Istio on Docker container, plain Docker container, in particular in Google Server Cloud Run. And as you know, in VMs and in other environments, since we don't have mutating webhook, we need to do something else. And the solution we have for VM, it's relatively complicated and doesn't work very well in Docker because it relies on saving some files. And obviously on Docker, you don't have any storage typically. So we have to do something slightly different. And while doing those changes, it becomes obvious that they benefit regular Kubernetes as well. So the goal here is to support, obviously, first goal is to support running Istio in non-Kubernetes environment or mutating webhook is not available. The second case is running Istio in clusters where you do not have mutating webhook permission. So if you run on you have a cluster, you have just the permission in your own namespace and nothing else. You cannot install mutating webhook, you cannot install CRDs, but you still want to participate in the mesh. And this is probably not very common, but it's identical with the Docker environment where you have a Docker container environment with nothing else available. And if we can support Docker, we can also support those use cases. I mean, for Kubernetes where you don't touch anything with cluster admin. And proxyless gRPC, which we are also starting to support in Istio, where again there is nothing to inject because they are not using a proxy, so they don't even need, but they still need to discover Istio-D. I have some brief discussion of use cases and trying to go over how people will use this mode. Please leave comments. Again, there are other use cases that are possible. There's just an example for what I think it's probably the most useful mode for this injectionless, but we can discuss. For regular clusters where we have injection, where we want to continue to use injection, this proposal is basically reducing the injection template to basically 5 lines, around 5 lines. I mean, just a container with the image, with the proxy, one container, init container with the image, no parameters, no volumes mounted, no absolutely nothing else except those 2 boilerplate lines, which are very similar to what we are doing for the gateway, except that in this mode, we don't even need to inject anything else because the startup will be able to detect it. And the benefit really for us not only is simplifying and reducing maintenance, but it also means that the workloads are no longer tightly coupled with the control plane, because Istio 1.9 has an injection template, Istio 1.10 has different injection template. When you upgrade from 1.9 to 1.10, you must do a rolling upgrade, you must change the control plane because obviously the parameters have changed in the injection and you don't know what's going to happen. It's yes, as John answered John's question on the sideline. Kubernetes case is a secondary case from me. I mean, my primary goal was to support Docker. It's just that accidentally, if we support Docker well, and those environments where injection is available, Kubernetes becomes very simple. And I think we should have a strong interest in simplifying the injection template in Kubernetes and supporting Kubernetes without mutating webhook, because upgrades and a lot of other things become trivial with and our support partner will become much smaller. But I didn't start to solve the Kubernetes problem; it just accidentally happened. But the solution is the same basically. I mean, it's a solution that solves both cases. So how it works and why it works. Right now, mutating webhook does the three things. It's adding the envoy and pilot agent, because we need obviously the mesh. It adds a bunch of environment variables that change from version to version. It adds volume mounts, including the token, and it, with a init container, it makes sure that IP tables are set up. I mean, the ultimate result of this injection is that IP table is set up and the sidecar is connected to the control plane. The solution for non-Kubernetes environment is basically to, like on VMs, we just add pilot agent with some changes that are proposed in this document, as well as envoy. We add them to the Docker image, and that has the same. It takes care of the first step, which is adding the binaries. Once this happens at startup, we change a bit the startup, so we do not depend on the environment variables. Instead of having inject or add some environment variables to the pod spec, the pod will make a lookup and get whatever that cluster needs in terms of environment variables and what is the configuration as an opaque curl request, HTTP request. The whole implementation is not dependent on any version of Istio. I have it working with Istio 1.9 and 1.10 because it really, Istio D doesn't care that some workloads happen to configure themselves in a different way. And yeah, let me go to explain the actual implementation, because the real trick here is to start with a config map that is using this system authenticated read permissions. That's really the key of this document. That's what made this happen. As you know, when the pod starts, it has Kubernetes IP, Kubernetes API server IP. It has a Kubernetes API server certificate, and it has a JOT token that allows connection to the Kubernetes API server. So what we are doing is we use those parameters, make a curl request to API server, and we get back all the environment variables that we need, plus XDS root certificate, plus everything else that injection typically does. And then we start pilot agent just as normal, I mean, with the parameters. If you are running outside, for example, in the case of Docker, in my particular example, I'm using some Google APIs to locate the JK server and get the IP and certificate. Obviously, that we can extend it to other platforms, or we can have other ways, or we can specify a URL that provides the same mesh environment that we need. And that's pretty much everything that is required here. There is some discussion about having this mesh environment file, which is again an opaque file. It's not. We don't want to repeat the mistakes of proxy config and other things where we have a strict specification. It's just some blob that is guaranteed to be retrieved from a URL. May change when the versions are upgraded, may be refreshed. But in the end, all it needs to do is to make sure the mesh is configured. The second interesting part here, and the second requirement for this design, is how to get the Istio-Scoped tokens, which are needed for CA and for other purposes. And for that, there are several options discussed. All of them work. A combination of them can be used. Pretty much, it relies on calling token request on API server, either from the pod or from an SPS server that would be bundled with Istio-D. Let me take a break to answer the comments on the margin. Feel free to ask as well. So API server access from proxy is not great. That's actually true to some extent. There is a project that is actually using accessing API server directly with HTTP request, because yes, there is a big library and has dependency and has all kind of issues with throttling and other things. But all we need to do is make an HTTP request to get a blob with a JOT token. So we don't really need the entire API server, and it's not necessary that API server is needed. You can configure to point to a storage bucket wherever and get the same mesh environment. I mean, we are just using the API server because it's most convenient and it's already there. So it's not.
If you can configure it to point to a bucket, then why don't you just configure it to point to Istio-D?
Because Istio-D, we don't have the purpose of getting this file is to get the certificate of Istio-D. To connect to Istio-D, you need Istio-D address, you need Istio-D certificate. We don't know them, so we cannot connect to Istio-D.
Well, don't we need to know the certificate of the bucket? Like you have to bootstrap somehow.
No. The bucket. I mean, Google Cloud Storage or Amazon Storage, which are used.
So it has a public cert, but Istio-D doesn't have a.
It has a public cert, exactly. Same thing with API server. I mean, we have the cert. It doesn't have public cert, but we have the key basically. And if you use external Istio-D or other things, again, you may not even know the address of Istio-D in the first place. It may not be Istio-D.Istio-System, because if you are running in a cluster, you don't have Istio-Systems, then what are you going to do?
Well, yeah, but you still need the URL of the bucket, so you still need, you need the URL of something, so why not just give it Istio-D? I don't know, I am very, very hesitant to doing this on Kubernetes itself. I mean, I get in a Docker environment, it's useful. And even in a VM environment, it may be there's cases where some people may want to do things today where they run Istio-Cuttle and copy files over, and some where they may want to effectively do that just from the VM on startup. But to do it in Kubernetes, I think is highly suspicious.
I understand your concern, and the Kubernetes is the last one that I'm planning to. So the plan is to support all others. Support Kubernetes where you don't have Istio-D, because I think we agree that it's a valid use case, or hopefully we agree that it's a valid use case. But if you have Istio-D, just use injection and you don't have to use this. Still, we can get it from Istio-D if we find a way to connect to Istio-D and what you're describing. But we still want to simplify the template. So it's still beneficial for us, even if you have Istio-D and even if you get this file from Istio-D, it's still useful to not have to inject all those 50 parameters.
Yeah, I think something like the bootstrap discovery stuff that we worked on.
It's very similar to bootstrap.
Yeah, you have minimal config to connect to Istio-D, and then Istio-D gives you the rest of the config instead of injecting it. I think that's reasonable.
But again, this minimal config, it's the address and the certificate, the root certificate, and instead of injecting those things, we just get them from Kubernetes because that's already taken care by the kubelet. So that's really simpler and same effect. And if we find out the API server doesn't work, then and latency is not impacted by this, because again, we make the same calls are made by the kubelet on our behalf to mount the token and mount the volume, and mount the config map that the agent will do. So it's not a change in number of requests to API server.
I don't know about that. I think it has more efficient watches. It can cache across. It's not like if you have 100 proxies, it's opening up 100 watches on the config map, right? It's opening one and using it. I assume it's pretty.
There is no watch involved. There is no watch involved in this design. So it's just a pure get on the API server, or two pull get. Mantar, you had
yeah. So I think the other use case of this, apart from sort of having common path for starting everything, is so it is forcing us to simplify the injection template, or at least hiding it, right? If not simplifying it. And it's also useful, I think, in sort of in-place upgrades, because one of the reasons why we just can't start a new version of proxy is because the template can change. So if we have this way of bootstrapping, which is get the end file. What are you calling it? Mesh env or something like that?
Yes, it is called mesh environment because it's not actually specific to Istio. It can be used with any other mesh that we may support,
Right.
including external
So,
Istio-D, external, yeah.
Right. So as long as you have the new bits available, the new bits of the proxy available wherever it wants to start, everything else is obtained from this sort of well-known endpoint. And yeah, and so I think I'm still not very clear on though how does this interact with the indirection that we get through revisions and webhooks. So as long as we do that uniformly, I think.
Yes, I didn't include this part in the document. Actually, I did include something at the end. So remember that what revisions do effectively is provide multiple Istio-Ds. So there are multiple Istio-Ds with different version, different. For Docker, again, you don't have revisions in cluster, you don't have mutating webhook, you don't select them to tag or anything. You have just this file. And the idea is that this file will list not one address, but multiple addresses of Istio-D, including for each revision and each. So basically, there is a controller that is looking at the cluster, finding what Istio-Ds are installed, and creates this opaque file that is understood by the pilot agent and is created by the controller. And it has a list of in-cluster, out-of-cluster Istio addresses. My recommended configuration is to have typically external, have a number of per region, per zone Istio-D, external Istio-D clusters where you store the configurations. And then you can have as many workload clusters where you just have workloads and you get a list of revisions and IP addresses of different Istio-Ds, and you pick one based on whatever you choose. I mean, you have access to your configuration. You can choose to select the canary or beta. If it doesn't work, you fall back to the other. You are no longer tied to, strictly coupled to a particular Istio-D by the injection template. You can pick anything you choose. Okay, let me get a bit into small, fancier IP table. Again, there is a discussion about IP table in this mode. Actually, let me go first to the golden image because that's where it starts. So normally in Istio, in Kubernetes, we have a pod running Fortio or book info, and we add a second container that is running Istio pilot agent and envoy. For Docker and VMs, really, what you have is a single container that includes pilot agent and envoy, the application. I'm calling it golden image because you have everything inside. That's typically maintained by the mesh admins and someone who provides this base image, including the preference operating system that is used in the enterprise or whatever. So this golden image is deployed in any Docker environment, can also be deployed in Kubernetes environment as an image. So it will be your application Fortio with mesh included, and you can deploy it anywhere. If you deploy it as a regular user in a regular cluster with no injection, it will know how to find the mesh environment and connect to the mesh and do everything that you are doing. The only thing that is a bit special is that you need to have IP table permissions or you need to have the CNI. So one of the two must exist, or we fall back to white box Istio, which still works. So it will effectively works everywhere, basically. And the other point I included in this document, which is a bit more, kind of far future, unless someone is volunteering to write the code. We can also inject Docker images directly. So there is a program called Code that is basically building a Go binary, and then it's patching, it's adding a layer to the manifest without actually using Docker itself. It's just uploading a targz as a layer, and then it's doing a small patch in the Docker file manifest. We can actually do the same thing. I mean, take any Docker container image, we run a command, and it automatically becomes a mesh-enabled Docker image, assuming it has, is based on libc, whatever envoy needs. Yeah, that's kind of the gist of this proposal. There are all kind of details and possible extensions. Yeah, go ahead.
The concept of the golden image, does it help with like the application container until your proxy is ready? Does it help with like lifecycle management of?
Oh yeah, it does. It does a lot. I mean, it simplifies everything, because the golden image contains a starter, which starts envoy, waits for envoy to be ready, starts for application, waits for application to be ready, and then declares itself ready.
I see. What about the shutdown time? Does it also help?
I haven't looked at shutdown yet. I mean,
okay, but it's pretty cool, yeah.
The prototype is, again, I started with the requirement for Docker where you cannot have a sidecar. And it's just that accidentally this image will also work in Kubernetes perfectly without any problem. Assuming you are willing to maintain an image or to patch an image to have, but again, if you're a developer and you run both Kubernetes and non-Kubernetes environments, you probably will patch the image for the non-Kubernetes environment, and then why not use it for Kubernetes as well, because you are testing it. One thing I forgot to mention, CI/CD. Everything that I described here, works in any Kubernetes, any Docker environment, including GitHub Actions, for example, or any other Google Cloud Builder. They know how to build a Docker image. You can run the Docker image. The Docker image can download the mesh environment, can connect to XDS, can have MTLS certificate, can do pretty much everything. So you can test your image in the CI/CD system with full, access control, whatever, mesh feature you are using, and then you can deploy it. So it's a bit more convenient for people who want to test end to end. Robert is asking, when do we write on the Bootstrap config for Envoy? I'm not making any changes to the Bootstrap config for Envoy in this proposal, Robert. So it's still exactly the same pilot. I mean, it's executing pilot agent, it's generating the same Bootstrap based on the same process.
And for that particular thing, we already have Bootstrap Discovery Service.
That already exists. I don't think it's enabled by default.
It's not enabled by default, but if the Bootstrap template changes during an upgrade, we can just call Bootstrap Discovery Service and get the right version injected. Or
technically.
No, go ahead.
No, I was going to say, technically, one of the things that I did part of this prototyping is to try to minimize the number of round trips to API server, because as John said, API server is a delicate server. So, and it impacts the startup time. So it is possible, the Bootstrap discovery, it's, going to XDS server, gets Bootstrap, save Bootstrap, starts Envoy, connects again to API server, to XDS server. We can put the Bootstrap in this mesh environment, which is completely opaque file, and then you save a round trip. That's the only thought I gave to this problem in the implementation. And again, since it's a single round trip at startup that needs to happen anyway, you save a bit, few 100 milliseconds in the startup time.
Right. I think that supports the use case where only Bootstrap template has changed in structure, but you're not introducing any new variables.
The launcher, because this relies on some binaries that is coordinating everything. The launcher could, check the mesh environment has pilot version change, download pilot agent, download, which knows a Bootstrap template, download the Envoy, and launch them again. So it's not really.
Right. Yeah. So it can do the whole thing, and then it would be repeatable and correct. At the cost of startup speed.
At the benefit of startup, because again, once you get the mesh environment, you have everything you need. I mean, you don't need to. I mean, assuming that the version doesn't change and you don't have to download Envoy, which is a different discussion. To answer Rob's comment, yes, that's something that is highly desirable but slightly orthogonal to this proposal. I mean, it will mean that you can go to Istio-D to get this mesh discovery file, assuming you know the address of Istio-D. I mean, somehow you need to know the IP address, and you can bake it in the image. Okay, Golden Image could bake a discovery or a set of discovery URLs where you are going to look up for addresses as well. So that's pretty much it. Please take a look, comment. I've been working on some prototype, and I'll try to publish it. What else should I mention here? Let's have after people have time to put comments and any strong objections to this proposal. I do not plan to make any changes to Istio itself at this moment because almost everything is in this binary that is completely agnostically to Istio and Istio versions. I'm planning to put it in an Istio ecosystem initially, get feedback, see how it works, and only after that discuss if we should add it to the main tree. The benefit is that since it's agnostic to version, people can try it and start using it to Istio 1.10, 1.11, whatever is the current version. We can get feedback and see without having to worry about upgrade and versions. And I mean, since one of the main goals is to decouple the Golden Image and the workload image from the control plane. And of course, go ahead.
Maybe I missed something. So the Golden Image, don't you have to update it with every single sidecar proxy version?
In recent Istio, I mean, we had a number of backward incompatible changes, but Istio master today works with control plane 1.9. Assuming, I mean, if you solve the problem of injection template, which is different, if you just take the envoy is really agnostic to almost agnostic to the version of the control plane in the last few versions, and we can make it a bit more strict in testing. I'm not saying that it's infinite. I mean, any version with any version, but 1.9, 1.10, 1.11, 1.12 are all more or less compatible. And don't forget, we are trying to add proxyless gRPC, which is completely different repository, different tree. And proxyless gRPC works not only with any version of Istio, but it also works with other XDS servers. So we will need at some point to have a bit of broader compatibility at the protocol level, XDS protocol level, which will allow us to decouple further from the current tight coupling.
Okay, so you're talking about the compatibility perspective. I could potentially have older version of my sidecar, but if user wants to move to newer version, maybe because we have an Envoy crash fix, or maybe it can gracefully shut down Envoy, then they would have to kind of rebuild their Golden Image to
absolutely.
pick up those. Okay. Just making sure, because today they don't have to do that with sidecar injector, right? They just need to restart their deployment.
I should mention for any Docker environment. So if you're not in exclusive Kubernetes shop, you build Docker image. You have a CI/CD that is building Docker images, and the requirements for such environments is that periodically, weekly, or whenever you are doing the build, you pick up any fixes from the operating system, from libraries, from any other binaries you are using in your Golden Image, including Envoy and Pilot Agent. So part of the CI/CD system that is building the Golden Image, and it's not specific to Istio or Envoy that it's a bug in Envoy, you need to pick it up. It can be libc, it can be OpenSSL, it can be anything else in the image. We are just not having a different process for security fixes in Envoy versus security fixes in OpenSSL.
Yeah, that makes sense.
I should make it more clear in the document that with Golden Image is responsibility of the mesh administrator for every week to build a new image and pick any security and critical bug fixes for anything, including operating system and Envoy at the same.
Same as VMs today, right?
Same with VMs today. We have the same requirement. If you are operating a VM, you need to do apt-get whatever to install the new Docker image. But it's not very clear to users that it's their responsibility, and they need to be sure to patch their images for everything, not only for Istio. And in Kubernetes, we benefit from this because, again, we don't have to have this alternate security patching mechanism where you have the sidecar updated. You update your images periodically to catch other fixes, and you get us for free.
Right, which is why I also agree what John mentioned earlier. It sounds like the existing sidecar injector model would continue to be the best for Kubernetes environment when when the mutating webhooks are allowed, and this would be a nice alternative for other environments or when they can't use mutating webhooks.
I mean, I agree with you if it's exclusive Kubernetes. If it's not exclusive Kubernetes, so if you have at least one Docker or CI/CD system and you need to maintain a golden image, then probably you are better off using the golden image and not using the injector at all, because you will test this image, control the rollout of this image. You are not you are using the same process for any security fix, and you don't have a split. If it's Istio security fix, do something. If it's something else, if it's libc security fix, you do something else. You have consistent across the board, controllable process for rollouts.
Yeah, that makes sense. And don't forget, we actually had an outstanding issue on VM, right? You can't run your service in Docker container with sidecar if you are running on VM. Sometimes the outbound traffic will conflict.
Yep.
So this, I assume, Custom, what you're proposing would actually hopefully solve that problem.
I tested extensively in Docker on my VM. I tested on Cloud Builder and GitHub Action. So I think it's working fine. In some Docker environments, the problem is you don't have traditional net admin capabilities, and that's where the fallback to white box comes into picture. And I submitted some patches to improve a bit the white box. And it works pretty nice now. I mean, if you're in HTTP proxy or connect, you change your code to connect to local host, it's relatively nice.
That's great.
Again, I'm just saying, it's prototype and proposal. Don't expect this to work tomorrow. But if we agree on this direction, I think we can make pretty fast progress, because there are not a lot of big changes really in this proposal. It's just, it's like small, taking the environment variables from injection template and putting them in a config map and few adjustments. John, yes, the main goal is containers, container service, but it accidentally also works on VMs with Docker, or it also accidentally works on regular VMs where you just debug. I'm typically developing on my machine. I click on run on the IDE, and it's doing kind of the same thing, basically. Yep. Okay, so if the other working group leads are okay with this, and after we get more feedback, it will be good to have some approvals. And I think, Lynn, you are now the master of Istio ecosystem, or?
Yeah, I'm one of the admins. Okay,
so after this approval, I'll maybe ask you to create a repository to start the prototype and some code.
Yeah, sure. Just let me know, like your repository name, a basic description for your repository.
I think we'll discuss this again. I mean, I just presented this. I don't think everyone had the time to absorb everything, and probably we need to figure out naming and what else we want to do about it. Other questions or concerns? We can, again, take next week or in 2 weeks to give people time to comment, to have another brief Q&A and figure out if we can move forward with this.
So just trying to understand John's comment. I think, John, you kind of indicate, like, if I have multiple different levels, assuming, I think you kind of indicate I don't really need this to run the services on Docker on top of my VM.
Yeah, I think the only case where you absolutely need this, I mean, unless you want to do everything manually, of course, that this is doing, is if you have basically a service where you just throw a container at it and it runs it. There's a lot of these, like, Cloud Build is an example, Cloud Run, or if I know my non-Google services, the AWS Lambda, maybe they have a container one as well. I think
GitHub Actions.
Yeah, GitHub Actions. Anything where you just throw one single container at it and it will run it for you. This would help. On a VM, if you want to use Docker, then that's fine. You could run Istio proxy already in another Docker container alongside it. You could run it on the host. Either one of those works. Like,
or you can throw
this could still be used to make it simpler. Like, in some cases, it may be simpler to do the current setup where you run Istio-Kettle and you pre-compute this and then stick it on the VM. In some, it's simpler to do it dynamically, probably most dynamically, to be honest. But it's not necessarily required in those cases. Like, you can still do Docker on VMs today.
Yeah, the real issue here is if you have a hybrid environment where you have both VMs, Docker services, container services, VMs, and whatever, you just build one golden image with your application, which is this proposal, and then you stick it, you throw it everywhere. You don't have to do things slightly different for VMs. I mean, it is possible to do a lot of different things. I mean, Kubernetes, you can have all the injection. On VMs, you can run proxy in a different container on the VM and so forth. But you can also just throw this image everywhere and it will stick mostly.
Okay, yeah, that makes sense. So today, we don't necessarily, there are workaround. I guess I forgot there is workaround. I guess you could run Docker on host network, or you could potentially with the IP flag you mentioned. So you don't necessarily have to use this, but it's nice if you run your services on different environments, which provides you the same image, whether you are running on Docker or run VM directly or running in Kube.
Yep. And another nice thing, if you're not using the workarounds, is that you can run as many as you want, because with the current workarounds, it's a bit more difficult. If you're running a host, you can have only one, and so it's a bit more inflexible if you use the workarounds than the golden image.
Mm-hmm. Yeah, that makes sense. Thanks for the clarification.
Okay, that's all I had.
I think so. I'm not super clear on how the upgrade UX would look from like a user standpoint. Like, how do they indicate what revision they want to like pull down the config for?
The main idea is that the config. I probably should have discussed a bit this. So the config is a config map with a bunch of environment variables, which are the current environment variables that we all know and love, and some extra with a CA certificate, which we currently use in the config map we create for distributing the root. The idea is that if you have multiple versions, if each version can add their own environment variables, if you use a different mesh, you can add more stuff. You cannot remove, and we need some compatibility. So the blob needs to be compatible with a range of versions. The upgrade scenario is the controller makes sure that the blob contains everything necessary for the versions installed in the system. So if you have Istio 110, 111, 112, and some external Istio-D, the controller will populate this blob with whatever is necessary for all of them by patching. And an important thing that we discuss is ability to, if the config map is flat, it's very easy to patch it from multiple controllers, and each version can maintain its own variables with patching without touching the other ones. At least that's how I implemented it so far. Now, the upgrade experience is the user picks whatever version of Istio, the current version of Istio in the weekly build of the golden image, and that is deployed, and that will pick the blob, which will have hopefully everything that is necessary inside. And if you have a different image with a different version or older, it still picks the same blob and has whatever the older version required.
Okay, so within the single config map, there are different, pretty much like environment variables and everything else per version, right? Like, or is it all pulling from like an aggregate?
To be honest, currently I'm just putting the default, but I didn't implement yet the fallback. I mean, how to check revision A, if it doesn't work, check revision B, or check extra. So, but the idea is that it's a list of config settings that will be the sum, the unification of all the active control planes that's available in the system, and the workload will pick whatever it. And I don't know exactly how we're going to pick, because this model doesn't rely on any annotations, templates, or labels. Or it's basically, probably it will be just an environment variable passed to your pod, your Docker image or container, where you specify the. Or we can continue to use the injection to take care of the label. Take the label and inject something to hint which revision you want to use. But I think it's important to have this fallback because it increases reliability. Because if the canary is bad, and if you try to deploy 112 or 115 and it has a problem, it's very useful for the pod to be able to say, hey, I cannot connect to XDSR, or I cannot get certificate. Okay, let's try the previous environment and not fail. Okay, back to this regular meeting. Any other topics for today? Sorry, I took a bit too long. Okay. If there are no other topics, 10 minutes back to everyone, and see you next week.
Thanks. See you next week.
Thanks, Austin. Thanks, everyone.